So welcome to today's class. Today we'll be learning about line integrals, what is arc length, what is differential displacement, what are conservative fields, and how to solve problems on these. Now if an object travels from x0, y0, z0 to x, y, z, then arc length implies the total distance travelled from x0, y0 to x, y, z, but while the displacement is a straight line. This is the arc length and it is given by this formula integral over c ds. The differential displacement is on the other hand is denoted by delta r, that is integral x0 y0 z0 to x y z ds. So arc length is a scalar and differential displacement is a vector. So arc length is given by the formula ds equal to square root of dx squared plus dy squared plus dz squared. In two dimensions it's square root of dx squared plus dy squared, or square root of 1 plus dy by dx the whole square. If the variables are in terms of a parameter t, then square root of dx squared plus dy squared plus dz squared becomes square root of dx by dt the whole squared plus dy by dt the whole squared plus dz by dt the whole squared. In Cartesian coordinates, the differential displacement is denoted by ds, that is I dx plus j dy plus k dz. It's a vector, and delta r is I times integral x0 to x dx plus integral j times integral y0 to y dy plus k times integral z0 to z dz. That is x minus x0 I plus y minus y0 j plus z minus z0 k. And the length of the net displacement is denoted by norm delta r, that is square root of x minus x0 the whole squared plus y minus y0 the whole squared plus z minus z0 the whole squared. An integral over a specific path is called a line integral. So integral over c a ds will be integral over c ax dx the x component plus integral over c the y component dy plus integral over c the z component dz. If a path c is a closed path, then the integral is a closed integral denoted by this symbol. Now a vector field is conservative if partial derivative of fx with respect to y equal to partial derivative of fy the y component with respect to x, or partial derivative with respect to z of the x component of f equal to partial derivative with respect to x of fz, and partial derivative of fz with respect to y equal to partial derivative of fy with respect to z. So we have something like a crisscross here. And the vector field is conservative if curl of f equal to 0. Now if integral over c f ds is path dependent, that is it gives the same value for every possible path, then f is conservative. And if integral over the closed path is 0 for every closed path, then f is conservative. So let's go through a few problems. Find the arc length and the net displacement from the origin to 4, 8 along the curve y equal to x raised to 3 by 2. Also find the magnitude of the net displacement. So arc length is given by integral over c ds, that is integral over c root dx squared plus dy squared, since we have only two components here. If I take out dx squared, it will be integral over c root dx squared into 1 plus dy by dx the whole square. So that will give you integral, take out dx, so it becomes 1 plus dy, it's basically just 1 plus dy by dx the whole squared here. So that will be integral over root 1 plus dy by dx the whole square, take out dx, so you get dx here. And look at your limits are from the origin to 4, 8. So it will be integral x equal to 0 to 4. Now y is x raised to 3 by 2. So dy by dx becomes 3 by 2 x raised to half, and that would give you 1 plus 3 by 2 x raised to half the whole square dx, that is 1 plus 9 by 4 x dx. Take out the 4, take the LCM, so you get root 4 plus 9x, square root of 4 is 2, so you get 1 by 2, integral 0 to 4 root 4 plus 9x dx. Integral of root x is x raised to 3 by 2. So this becomes 4 plus 9x raised to 3 by 2 by 3 by 2. because integral of root x is x raised to 3 by 2 by 3 by 2 divided by derivative of 4 plus 9x is 9 within the limit 0 to 4. So substituting, you get it as 9.4. What about the net displacement? Net displacement delta r is I times integral x0 to x dx plus j times integral y0 to y dy. We have seen that formula. That will be x minus x0 I plus y minus y0 j. Now x0 y0 is the origin and xy is 4, 8. So this becomes 4i plus 8j. And the magnitude of the net displacement will be norm delta r, that is root 16 plus 64, which is root 80, which is approximately 8.95. Coming to the next question, find the arc length from the origin to pi by 2, 1 along the curve r equal to sine theta. Now using polar coordinates, s equal to integral over c ds. That is integral over c root dr square plus r square d theta squared. So dividing by theta, you get dr by d theta the whole squared plus r squared d theta squared. That will be integral over c dr by d theta the whole squared plus r squared, take out d theta squared, which is d theta. Now dr by d theta is cos theta, so substituting, you get integral. In polar coordinates, actually theta lies between 0 to 2 pi, but here you are given it is from the origin to pi by 2, 1. So theta will lie between 0 to pi by 2. Root of dr by d theta will be cos squared theta, r squared is sine squared theta, cos squared theta plus sine squared theta is 1. So this is theta within the limit 0 to pi by 2, which is pi by 2. Coming to the last question for today. Evaluate integral over c f ds for f equal to x squared y squared I plus x cubed yj from the origin to 1, 2 along the line y equal to 2x and along the route 0, 0 to 1, 0 to 1, 2, and is f conservative. So first we calculate along this origin to 1, 2. So integral over c f ds will be integral over c the x component, which is x squared y squared dx, plus integral over c the y component, which is x cubed y dy. Now along y equal to 2x, so x equal to y by 2. So substituting, we get integral over c x squared y squared becomes 4x squared dx plus integral over c y raised to 4 by 8 dy. Now x goes from 0 to 1. So it will be integral x equal to 0 to 1 and y will go from 0 to 2, origin to 2. So integral 0 to 2 y raised to 4 by 8 dy. Integral of x raised to 4 is x raised to 5 by 5 within the limit 0 to 1 plus 1 by 8. Integral of y raised to 4 is again y raised to 5 by 5 within the limit 0 to 2. So you get 8 by 5 as the answer. Now consider the root from 0, 0 to 1, 0. Here y is 0 and from 1, 0 to 1, 2 x is 1. So using this integral over c f ds will be again integral over c the x component, which is fx dx, plus integral over c the y component, which is fy dy. Now the x component is x squared y squared, but x is 0, so it becomes integral over c x equal to 0 to 1, y is 0, so dx, and along the y component y is 1, x is 1, so it becomes just y, and y will be 0 to 2, y dy. So integrating, you get y squared by 2, which is 1, which is 2 here. So along the first integral it was 8 by 5 and along the second path it is 2, so f is not conservative. So that brings us to the end of today's class. We have seen what is arc length and what is differential displacement, what is a conservative field, how to calculate the arc length and the norm of the arc length vector, and to check if a vector field is conservative in polar coordinates as well. Thank you.